Hi. Today we are going to discuss about binary search trees. First of all, we should know what is a binary search tree and how to add nodes to a binary search tree. First one, what is a binary search tree? Definition. A binary search tree is a binary tree that is either empty or in which every node contains a key and satisfies the following conditions. First condition, the key in the left child of a node is less than the key in its parent node. Second condition is the key in the right child of a node is greater than the key in its parent node. Third one is the left and right subtrees of the root are again binary search trees. Fourth one is no two entries in a binary search tree may have equal keys. Figure shows a binary search tree. Here there is a root, it is having a value called 10 and there are so many nodes, every node contains a key and it is a binary tree. So figure shows a binary tree. We have to check whether it is a binary search tree or not. If it satisfies the conditions we have mentioned in here, then this binary tree is said to be a binary search tree. The first condition is the key in the left child of a node is less than the key in its parent node. So parent, say root is parent, 6 is child. So 6 is left child, left key. Left value is less than root value and second condition is right value is greater than root value. See, root is 10, its left value is 6, its right value is 20. So left is less than root, right is greater than root. So left 6 is less than 10, 6 is less than 10, then here 20 is greater than 10. Left value is less than root value, right value is greater than root value. Again left and right are binary search trees. Again the left tree is a binary subtree is a binary search tree and right subtree is again binary search tree. See here 6 is root, 4 is left value, 8 is right value. So 4 is less than 6, 8 is greater than 6. In the second one 20, 15, 30. 20 is root, 15 is left value, 30 is right value. 15 is less than 20, left is less than root. Here right is greater than root, 30 is greater than 20. So left child is less than its parent value, right child is greater than its parent value. 4. 4 is child of 6. 4 is less than 6. Left child is greater less than parent value. Right child is greater than parent value. So if it satisfies this kind of conditions, then that binary tree is said to be a binary search tree. So this is a binary tree as well as a binary search tree. And no two entries in a binary search tree may have equal keys. None of the values are equal to any other value. So there are no duplicate values. So the conditions are left value should be less than root value, right value should be greater than root value, left and right are again binary search trees. There should not be any duplicate values. Now let me explain creation of a binary search tree with an example. Creating a binary search tree with the following keys 10, 8, 15, 25, 22, 30. The step-by-step creation of binary search tree by inserting nodes one by one. So first I have to insert node 10. So the first node that is going to be inserted into a binary tree becomes root node. The first node is root node. Next I have to add another node called 8 with information 8. Create a node with information 8 and compare with root node. And the conditions are the node which is less than root value should come in the left subtree of root. So 8 is less than 10, it should come in the left subtree. So left is empty, there are no nodes, we can add a node here. So 8 is added as left node of 10. Then add node with information 15. Again start comparing with root node. Is 15 less than 10? No. Is 15 greater than 10? Yes. So the value that is greater than a node should come in the right side of that node. So it should come in the right subtree of 10. So is right null? Yes, right is null. So 15 can be added as right subtree of 10. Then add 25. Again start comparing with root node. Is 25 to be added in the left subtree or right subtree? As 25 is greater than 10, it should come in the right subtree. But right is already filled. Right is, there is a node, right node is there. Go to that node and again start comparing with 25. Is 25 to be added as left node of 15 or right node of 15? As 25 is greater than 15, it should come in the right side of 15. So right side of 15 is empty, so it is added as right node of 15. Then add 22. So to add 22, again start comparing with root node. Every time we need to add a node, that node to be compared starting with root node. Is 22 less than 10 or greater than 10? It is greater than 10. So it should come in the right subtree of 10. So is right null? No. So we go to right node 15. Now the pointer is pointing to 15. Is 22 greater than 15 or less than 15? It is greater than 15. It should come in the right subtree. Is right null? No. Right is already filled. Go to right node. Is 22 less than 25 or greater than 25? It is less than 25. It should come in the left subtree of 25. So we check. Is left of 25 null? Yes. Left of 25 is null. So 22 is placed as left node of 25. Then try to add node 30. Again start comparing with the 10. Is 30 less than 10? No. Is 30 greater than 10? Yes. It should come in the right subtree. But right is not null. Go to right node. Compare 30 with right node. Is 30 less than 15? No. Is 30 greater than 15? Yes. So it should come in the right subtree. Is right null? No. So you have to go to right node. Compare 30 with 25. Is 30 less than 25? No. Is 30 greater than 25? Yes. It should come in the right subtree. Is right null? Yes. So you can add a node as right node of 25, 30. So in this fashion we can add all the nodes. First node is root node and remaining nodes may be added using the conditions specified there. Now verify whether all the left nodes are less than parent value and all the right nodes are greater than parent value. Is there any duplicate values? See, 8 is less than 10, 15 is greater than 10, then 25 is greater than 15, so 22 is less than 25, 30 is greater than 25. So suppose if you take this particular subtree, 25 is parent, 22 is left node, 30 is right node. 22 left node is less than root node and right node is greater than root node. Here 15 is root node, there is no left node, there is only right nodes. So 15, right node is 25, 25 is greater than 15. In this fashion, we have added all the nodes as a binary search tree. For clarity, that was clearly mentioned in here 10, 8, 15, 25, 22, 30. Everywhere the nodes are specified as per the rules specified there. The first rule is left value is less than parent value, right value is greater than parent value, left and right are again binary search trees, and fourth one is there are no duplicate values. There are no duplicate values. If a particular binary tree satisfies all these four conditions, that particular binary tree is said to be a binary search tree. So this is a binary search tree. BST, binary search tree. Let me explain how to create a binary search tree with the following values. There are 14, 4, 15, 3, 9, 18, 16, 27, 5, 17. I'm trying to add nodes one by one to create a binary search tree. Normally, the first node is root node. So 14, add 14. Initially, binary tree is null. Now, I'm trying to add a node with information 14. That could be the first node. So that is root node. Now, add 4. Create a node with information 4. Start comparing with root node. Is 4 less than 14 or greater than 14? It is less than 14. It should come in the left subtree. Is left of 14 free, empty? Yes, it is. So left of 14 is empty. So we can add a node comfortably in the left side of 14. So 4 is added as left node. Then try to add 15. Again start comparing with root node. Is 15 less than 14? No. Is 15 greater than 14? Yes. So as the new node is greater than root node, it should come in the right subtree. Is right null? Is there a vacancy? Yes. Right of 14 is null. So add 15 as right node of 14. Now add node with information 3. Again start with 14, root node. Is 3 less than 14? Yes. 3 is less than 14. It should come in the left subtree. Is left free? No, left is not free. Go to left node. Now, your pointer is pointing to 4. Is 3 less than 4? Yes, 3 is less than 4. So, it should come in the left subtree of 4. So, is left free? Yes. So, add a node in the at the left side of 4. Then, try to add node 9. Again start comparing with the root node. Every time you wanted to add a new node, that has to be compared with root node. Is 9 less than 14? Yes, 9 is less than 14. It should come in the left subtree. Is left free? No, left is already filled with some node 4. Go to left node. Now pointer pointing to 4. Is 9 less than 4? No. Is 9 greater than 4? Yes. So it should come in the right side. Right side of 4. Is right side of 4 empty? Yes. So you can add a node 9 at right of 4. Then 18. Try to add node with information 18 or with key 18. Again start comparing with root node. Is 18 less than 14? No. Is 18 greater than 14? Yes. So 18 should come in the right subtree of 14. Is right null? No. Right is not null. Right is having a node with information 15. Now compare 18 with 15. Is 18 greater than 15 or less than 15? It is greater than 15. It should come in the right side of 15. It should come in the right of 15. Is right null? Yes, right is null. So add a node at right side of 15. So 18 is added as right node of 15. Now 16. Add node 16. So to add a node 16, again we start comparing with root node. Is 16 greater than 14? Yes, 16 is greater than 14. It should come in the right subtree. Is right null? No, right is not null. Go to right node. Now the pointer is pointing to 15. Is 16 greater than 15? Yes, 16 is greater than 15. It should come in the right subtree. It should come in the right subtree of 15. Is right null? No, right is not null. Again go to right node. Is 16 greater than 18 or less than 18? I have to compare. So 16 is less than 18. Is it should come in the left side of 18. Is left of 18 null? Yes, it is empty. So you can add 16 as left node of 18. Then add node with information 20. Again start comparing with 14, that is root node. Is 20 greater than 15? Yes. So it should come in the right subtree. Right is not null. Go to right node. Is 20 greater than 15? Yes, it is greater than 15. So is right null? No. Go to right node. Is 20 greater than 18? Yes. So is right of 18 null? Yes, it is null. So 20 is added at right of 18. Then try to add node 7. Again start comparing with root node. Is 7 less than 14 or greater than 14? It is less than 14. It should come in the left subtree, but left is filled. Go to left node. Now here 4. Is 7 less than 4 or greater than 4? It is greater than 4. It should come in the right subtree, but right is not empty. Go to right node. Is 7 less than 9 or greater than 9? Less than 9. It should come in the left subtree. Is left of 9 free? Yes. So you can add 7 as a left node of 9. Then 5. Again start comparing with root node. Is 5 less than 14? Yes. So 5 is less than 14 and it should come in the left subtree, but left is not null. Left is not null. It is already filled with some node. Go to that node. Again comparing 5 with that node. Is 5 less than 4? No. Is 5 greater than 4? Yes, it should come in the right subtree. So go to right subtree. Now compare. Is 7 less than 9? Yes, less than 9. Is left of 9 null? No, it is not null. It is having some node. Go to that node. Is 5 less than 7? Yes. So is left of 7 null? Yes. So 5 is placed as left node of 7. 5 is placed as left node of 7. Then add 17. Again start comparing with 14. Is 17 greater than 14? Yes. So it should come in the right subtree. Right is not null. Right is not null. Go to right node. Is 17 greater than 15? Yes. So 17 is greater than 15. It should come in the right subtree. But right of 15 is already filled. Go to right node. Is 17 greater than 18 or less than 18? It is less than 18. It should come in the left subtree. But left is already filled. Go to 16. Is 17 greater than 16 or less than 16? It is greater than 16. It should come in the right subtree. So is right of 16 null? Yes, it is null. So we can add 17 as right side of right node of 16. Now we have managed to add all the nodes. Check whether it is a binary search tree or not. Everywhere, see, the left value is less than its parent value, right value is greater than its parent value. See, 4 is less than 14, 15 is greater than 14. Here, 3 is less than 4, 9 is greater than 4, and 7 is left to 9. So 7 is less than 9. Then 5, 7. 5 is left of 7. So 5 is less than 7. Here 15 and 18. So 15, 18. 18 is right side. So 15, 18. 18 is greater than 15. So here 16, 18, 20. Left node is having less value than parent value and right node is having greater than parent value. So 16 is less than 18, 20 is greater than 18. See here at this particular stage 16, 17. 16 is parent, 17 is its right node. So right node is greater than root node. So everywhere it is satisfying the three conditions. First one is left value should be less than parent value, right value should be greater than parent value. Again, left and right are binary search trees and there are no duplicate values. So we have constructed a binary search tree in this fashion. So like this, we can create any binary search tree with given values. We should know that the first value we have inserted or adding is going to be the root node. So once a root is created, you can compare the nodes next on to be added to binary search tree. So whatever the node you wanted to add, you start comparing with root node. If it is less than root node or it is greater than root node. If it is less than root node, it has to come in the left subtree. If it is greater than root node, it has to be it should be added to the right subtree. Let me explain the function to add a node to a binary search tree. For example, assume that there is a binary search tree with only one node. Say, let us take a node with information 10, which is root node. Left is null, right is null. Now, I'm trying to add a node with some function. I'm calling build tree function. Build tree root comma 20. I wanted to add a node with information 20. Now I'm calling build tree function. So this is a build tree function. The input is tree node and int. Tree node is root, int is some 20. So in the function, the root is called p. Now this is p. See, I wanted to add a new node. I have to create a new node. For that, I have taken a local variable called q. Q is a tree node. If x is p data, if greater than p data, what is x? Value of new node to be added. So what is the value of new node? It is 20. Is 20 greater than P data? What is P? P is root. P is root. Root data is 10. Is 20 greater than P data? Yes. 20 is greater than P data. New node is with information 20. It should be added as right node of the root node. So if value is greater than root value, it should be added in the right side. Now I have to check, is right of P null? Yes, P right is null. There is no node. So I can add a new node there. Allocate memory, create memory to a new node Q. A node is created. It is Q. Then Q data is X. X is 20. Q left is null. Left is null. Q right is null. So a new node is created. Then P right is Q. P right is already assigned to null. It is assigned to Q. Now there is a binary search tree with two nodes. 10 is root node and 20 is added as right node. So right node is having value greater than its parent value. So it's satisfying binary search tree condition. Now try to add one more node. Build tree. Build tree. Root comma 5. Root comma 5. Again, I'm trying to add a new node. I'm trying to add a new node to the already existing binary search tree. So binary tree is already containing two nodes, 10, 20. 10 is root node. 10 is root node. Now I'm calling build tree root comma 5. So root is my P. So root becomes P in the function. Then x is 5. Now x is 5. Is 5 greater than P data? What is P data? 10. Is 5 greater than P data? No, it is less than P data. So it is false. So directly it goes to else part. It is not greater than P data. So else. If x greater than x less than P data, what is x? X is 5. What is P data? 10. Is 5 less than P data? Yes, 5 is less than P data. So it should be added in the left subtree. Is left null? Yes, left of 10 is null. So create a new node to be added. Allocate memory, memory allocation, allocate memory for Q. How much memory? Per a memory equivalent to tree node. Then Q data is X. What is X? X is 5. 5 is placed in key position. Then Q left is null. Q right is null. Q left is null. Q right is null. A new node is created. Then P left is Q. P left is already null. It is pointing to Q. Now 5 is added as left node of 10. See here, as far as this is concerned, this is a binary search tree. This is a binary search tree where it contains three nodes. First node is root node 10. Its left is 5. Left node contains less than root value. Right is 20. Right node contains greater than root value. Left value is less than parent value. Right value is greater than parent value. So we have added two nodes in here. By adding two nodes, we have created a binary search tree.